We're going to go through some examples now of SAL expressions and functions and using unit generators. Some of these will cover or introduce concepts that you haven't learned about yet, so don't really worry about it. We'll get to them eventually. And right now, what I want to do is just kind of give you the feel of some things you can do, and hopefully you'll find this interesting. All right, so the first example is we're going to load the piano synthesis library and play a piano note. What I'm doing here is highlighting expressions, and I'm using Command U on a Mac to execute them. I believe you can do this with Control U under Windows. And okay, so now we've got a sound going. Here we're going to take what we just did and multiply it by a piecewise linear envelope function, and this will sort of change the amplitude shape of the sound. So we removed the sharp attack at the beginning by ramping up slowly, and the duration was slower. So another thing we can do with functions is encapsulate expressions. So here I've got defining a new function called piano for piano that just returns this longer expression, and I've done the same thing with env1, and now I'm saying PE, so piano with an envelope, is the product of piano and envelope 1, and now we can plot it to see what it looks like. And here up in the plot window, you can see this enveloped piano sound. If we wanted to plot just the envelope, we can do that. That's the envelope. And now let's play this whole thing multiplied by a 5 Hertz sinusoid, which is constructed by this LFO, which means low frequency oscillator. All right, great. Now we can change the length of the LFO. That was an LFO of default length 1, which sort of cut things off here in the envelope. We didn't hear the whole thing. So we'll add the second parameter 1.6 to the LFO to get the full sound. Now you get to hear it fade out. Let's plot the LFO. That's what the LFO looks like. And we'll plot the sound that we played. Now you can see this sort of the product of the piano with the LFO is this pulsing sound that we just heard. Okay, let's do something a little more harsh. Here's the OSC pulse unit generator, produces a pulse wave. Oh, if I add 1 to it, it looks the same, but the vertical axis, now you see this thing goes from 0 to 2. And so now what we're going to do is multiply PE, this piano sound, by this pulse wave. Okay, that is a little more harsh. We can modulate the frequency of the pulses. Let's build an envelope called pulseFreq and define that function. And we can now plot it. So you see this pulse getting faster and faster according to this envelope. And now, if we play our enveloped piano sound multiplied by these pulses, what happens? Okay, that's kind of interesting. Now we have some code to make some classic table lookup instruments. Let's first of all look at what table looks like, and we'll play oscillator using this table. Okay, We're going to redefine table to be a bunch of harmonics that you see here. And now the table looks like this. We're going to play it. All right, much brighter. And we can take this and multiply it by an envelope. Okay, that's a little more musical. And we'll do our standard encapsulation trick. We'll define a function called bright that just returns the expression we just computed. So now we can use bright in a function, like we can play a sequence of 10 evaluations of bright where the pitch is C4 plus a random number, and let's see what we get. I forgot to mention there's a stretch operator right here. So we were stretching by random durations as well. Okay, and we can put all of this into another function called little piece. And let's play it one more time. Wow, why did that come out so low? It's because I changed the code a little bit here. We're playing pitches based on at C2, which is 2 octaves below middle C. Okay, now let's multiply this whole thing by an envelope. Okay, so you heard those notes get louder and softer following the contour of the envelope. You know, if you want to see what that envelope was, let's copy that, and up in the command I'll say exec splot. Here's the envelope, and I think I need to give it, let's try that again with a duration. What was the duration of this thing? Well, let's put in 10 seconds. Okay, so that's what the envelope looked like. We can play the same piece, but multiplying it by a sine function pitched at A4. So this is doing some ring modulation. And we can take the whole thing and multiply it by a low frequency sine. Good, so I think we'll stop there. Those are some examples of using Nyquist, writing expressions with unit generators, combining them to make some interesting, hopefully somewhat interesting sounds.